Howdy, ladies and gentlemen. Hope everybody's doing good. We have got a very important lesson video for you here. We are going to talk about solving multi-step equations. This is going to be one of the foundations for everything we do the rest of this year and for algebra moving forward. Accuracy, precision is of the utmost importance. Pay very close attention to integer rules. Do not try and do too much in your head. If you're trying to do too many steps in your head, you're going to make careless mistakes. This is a unit where even if you know what you're doing, you can still make careless mistakes. And then there's the layers that get added onto this. It is really important that you stay caught up with your homework on this unit as well. So we're going to begin with our solving equations unit here. So let's go ahead and get our dot cam set up to review some of the basics from prior years. So we're going to just tap into some prior knowledge before we get to our notes. If you have not already looked on your Teams page, you should go find your notes on solving equations because we're going to go use them. If you don't have them yet, or if you can't print them, you'll want to put them in your notebook because it's going to be a checklist. It's your roadmap. So let's go ahead and review some prior learning here. So we're going to start with some basic two-step equations. And then what is essentially a three-step equation. So the first thing with two-step equations, if we review 6th and 7th grade, is we're always going to want to isolate the variable. That is your goal. Now, how we do that is going to differ as problems become more complex. With a two-step equation, we're always going to be looking to undo addition and subtraction first. So for this example here, my goal is to get x alone, and I'm going to start with undoing the plus 5 with a minus 5. When I solve an algebra equation, I'm going to work my way down. I would highly recommend you do the same. Now, you don't have to, but I think that when it comes to the process of solving an equation, it will be a little bit easier. The reason why we subtract 5 is because the opposite of plus 5 is minus 5. When those two things combine, it makes 0, which means it's gone. We are one step closer to isolating x. 11 minus 5 is 6. Bring the equal sign straight down. The plus 5 and the minus 5 make 0, so it is gone. The 3x comes straight down. The first step is to undo addition subtraction. The second is to undo the multiplication and division. The x is touching 3, which means multiply. The opposite of multiply is divide. Whatever I do to one side of the equation, I have to balance it. I have to do the exact same thing to the other side. Why do we divide by 3? Well, if I have 3 on the top and the bottom of a fraction, those things reduce away down to 1, which now means I have 1x, which means the x is now alone. And then 6 divided by 3 is 2. So a basic two-step equation just to review. The second example, we have x over 2, which means division, plus 7 equals 15. So we're going to start by undoing the addition and subtraction. So we're going to subtract 7 to both sides. The 7's cancel out because they make 0. 15 minus 7 is 8. Bring down the equals. Bring down the x divided by 2. X divided by 2 means division. So we're going to multiply. Now this step is key, the way in which I want you to show it. We are going to multiply by 2. I want you to put the 2 next to the fraction because it's going to be important to understand why. I put it next to the fraction because it essentially is 2 over 1. Well, that means those 2's cross-reduce. That's what gets x alone. And so now I have x equals 16. Now my guess is you probably could have done these in your head, but the process is so important. The third example, which is hopefully review, is what happens if the x, along with the 3 and the minus 12, is all trapped in a fraction. Anytime something's trapped in a fraction, we want to free it from the fraction. Well, what makes a fraction? It's division. Well, think back to example number 2. I undid division with multiplication. Well, because this entire thing is trapped, I cannot undo the minus 12 yet because it's trapped in a fraction. So we're going to free it from the fraction by multiplying the entire thing by 2 over 1. And I'm going to maintain my balance. Whatever I do to one side, I do to the other. So the 2's will reduce away, and I get 18. Bring down the equals, and the 3x minus 12 is now free. Now it's just a basic two-step equation. So we'll add 12 to both sides. And I get 3x equals 30. And then I'll divide out the 3. And I get x equals 10. So some basic review of your simple solving equations from 6th and 7th grade. Now let's talk about what happens when these things get a little more intense. In your notes, you're going to have the step-by-step process to solving linear equations. This is how you're going to solve multi-step equations. Now, there are other ways to get through it, and if you get to be, mathematicians, expert mathematicians, you'll understand when you can do things a little bit differently. But right now, this is your roadmap. This is your step-by-step process. If you follow this step-by-step process and you do not work out of order, you do not wander off and do your own, you will be able to get to a basic two-step equation every time. These last two right here, that's a two-step equation. So if you do steps 1, 2, and 3 in that order correctly and fully, you will have a two-step equation at the end every time. Our goal is still the same. Your goal is to get the variable alone. Identify what the variable is that you're trying to get alone. Now, some of these equations are going to have more than one variable. Step number 1, get rid of the parentheses. Distribute. You need to get rid of your parentheses first, and distribution is the best way to do that. Step 2, combine like terms on each side of the equals. The equal sign is going to create a barrier. And then step 3, move the variable to one side. And I recommend that you move the smaller one. You do not have to, but moving the smaller one will give you less negatives. And as you guys are going to discover as we work through this, negative signs are going to be one of those things that will give you some difficulties. Okay? So we're going to have this checklist, and let's take a look then at solving a couple of examples using this checklist. So hopefully you have your checklist out. If you do not, pause the video right now and go print it, or pause the video right now and write this down in your notebook, and then come back to our example problems. So example number 1 is going to be using our distributive property and like terms that we worked on previously. Step number 1 in your notes is to get rid of parentheses. So I have a -5 that will distribute into these parentheses. Remember, the sign to the left stays attached. So -5 times x is -5x. -5 times 3 is -15. I'm going to get rid of my parentheses. Bring everything straight down. Bring down the 8x, bring down the equals, bring down the -9. Now remember, we talked about the barrier. This equal sign is a barrier. You cannot do anything through the barrier. You can move things around it, but you can't do anything through the barrier. Step 2 in your notes, if you're looking at them right now, says combine like terms on the same side of the equals. So on the left side of the equals, I have like terms 8x, -5x. The -15 and the -9 are not allowed to combine because they are not on the same side of the equals. So let's combine the 8x and the -5x, giving me 3x. Bring everything straight down. Now something should jump out at you right now. This is a two-step equation. We didn't even need to use rule number 3 or step number 3. It jumps straight to a two-step equation. So now I will add 15 to both sides. The 15s make 0 and cancel out. I'm going to bring down my 3x. I'm going to bring down my equals. Integers, be very careful here. A -9 and a +15 is going to make 6. And then I'm going to divide, and x equals 2. All right, so get rid of parentheses, combine like terms. This one jumps straight into a two-step. The next example is going to basically be the exact same idea as the first example, except it's just a little more intense. So let's just look at what an example that's a little more intense. As long as you follow your step-by-step process and don't break from it, you'll be fine. So step number one is distribute. Well, I have a -4 to distribute, and I have a -3 to distribute. We'll distribute and bring everything straight down. So -4 times 3x is -12x. -4 times 1 is -4. -3 times 6 is -18. And -3 times -3x is positive 9x. Bring everything else down. There's a 9 in front. Bring it down. Equal sign. Bring it straight down. -1. Bring it straight down. I'm going to put my little barrier in here, my equal sign. So step one is complete. I have removed the parentheses by distribution. Let's combine like terms. We have quite a bit of like terms here. I have a -12x and a positive 9x. I have a 9, a -4, and a -18. You'll notice I underline and double underline. You can put boxes around things. You can circle them. You can do whatever helps you visually to do it. Some of you might even get colored highlighters. And as you see these terms, you'll just highlight them yellow, highlight them orange, whatever you like. Integer rules are super important here. A -12x and a positive 9x is going to make -3x. 9 and -4 and -18 will all combine. Remember, I am not going to include the -1 because it's on the other side of my barrier. Well, 9 and -4 is 5. 5 and -18 is going to make -13. Bring down the equals, bring down the -1. You'll notice I kind of exaggerate lining everything up here. One of the recommendations I make for a lot of algebra students who maybe struggle just a little bit with their neatness or organization is use grid paper. Grid paper will help you organize and line everything up naturally. Well, what do we notice? Two-step equation. So I'm undoing the -13 with a positive. And I'm going to keep my balance and do it to both sides. I'm left with -3x equals a positive 12. I will divide out the -3, and x equals -4. Precision is so important. This particular problem had 1, 2, 3, 4, 5, 6, 7, 8, 9 steps to it. And all 9 of those steps required you to remember your integer rules. Any one of those 9 steps you rush through or you're inaccurate on, and it will cost you in the end. So be careful. Let's take a look at the last example. And again, I am going to encourage you to have out your notes. Look at your notes as you are going through. I'm going to bring them back to remind us here. All right. Have these out. This is your checklist. You want to write on it, do whatever you have to do. Do not wander off and just do your own thing. I now have variables on both sides of the equals. All right. This is going to take us into a later phase. You do not have to do all of this on night 1. So really, night 1 is what you have seen so far. Once we venture into the second half of equations, then you're going to get to variables on both sides. The roadmap, the step-by-step process is still the same. Step 1, get rid of parentheses. So I'm going to distribute. And on the other side, I'm going to distribute. So 3 times 2x is 6x. 3 times 5 is -15. Over here, I'm going to get -10x and plus 14. And everything else, I'm bringing straight down. Plus 7x and the equal sign are coming straight down. Step 2 said combine like terms that are on the same side of the equals. So remember, the equals is your barrier. On the left side of the equals, I have a 6x and a 7x that I can combine, which is going to make 13x. Bring down the minus 15, bring down the equals. There are no like terms over here, so I'm simply going to bring down the negative 10x plus the 14. Now this one has step 3, which is to move the variables to one side, and I recommend you move the smaller one. Well, in this case, the negative 10 is the smaller one. I want to, for a moment, though, go back to some of our basics when it came to solving equations. So if I go all the way back to a 2-step, how did I make the plus 5 disappear? I subtracted it because plus 5 and minus 5 made 0. Plus 7 and minus 7 made 0. That same idea from a 2-step is going to be how I move a variable to the other side. So what could I combine with negative 10x that would make 0 and make it disappear? If you were thinking plus 10x, you were exactly correct, because the minus 10x and the plus 10x will cancel each other out. I have to maintain balance. So if I'm going to add 10x to one side so I can cancel out the negative, I have to add 10x to the other side. And this is what I mean when I say I'm moving the x's to one side. I'm making them cancel out on this side, and then the 10x will move to the other side. Well, 13 and 10x makes 23x. I'm going to bring down the 15. I'm going to bring down the equal sign. The 10x's have canceled out, and I have 14. If I recognize correctly, I have a 2-step equation. My goal is to get x alone, so I'm going to add 15 to both sides. And I'm going to get 23x equals 29. I'm going to get the x alone. And this is where some of us are going to struggle. They will not all be perfect answers. This answer is a fraction, and you're going to have to get comfortable with fractional answers, which is going to be a challenge because the fractional answers are the ones that you can't do mentally, but there's also a certain level of trust that you have to have. You've got to trust that you did the steps correctly, because 29 over 23 is not an answer that we're used to seeing. All right, so it's just going to be one of those where you have to be careful. Let's go ahead and put an example in here for you to try. So let's set up an example problem that reads, and let's just make something up here. So chances are it's going to be a fractional answer. And let's just add a negative 11 there. There we go. So go ahead and pause the video and work this problem out as an example, and then we'll see how you did. All right, welcome back. Let's see how you did on this particular problem here. We're going to go ahead and set in our barrier. We're going to work through this rather quickly. Step 1 is get rid of parentheses, so I'm going to distribute. And I'm going to get negative 8x minus 10. And I'm going to get 6x plus 15. I'm going to bring everything else down that I have not used. I have to combine like terms on the same side of the equals, and so when I do that, I'm going to combine these here. And on the other side, I'm going to combine these here. This is going to give me negative 8x minus 18 equals, and this is going to give me 6x plus 4. I'm going to take a moment just to look to make sure I haven't made any mistakes before I keep going. So I distribute here. I like that. Distribute here. I like that. Combine my like terms. Good. I have variables on both sides of the equals. I'm going to move the smaller one, which is the negative 8. So I'm going to add 8x to both sides. If you wanted to move the 6, you could have. The only difference is at the end, your variable will be on the other side of the equals. The 8x's cancel out. Negative 18 equals 6 plus 8x is 14. X plus 4. I'm going to subtract 4. That's going to leave me with negative 22 equals 14x. Divide out the 14 on both sides, and x will equal, don't forget to reduce, negative 11/7. I want you to notice that for this particular problem, the x ended up on the right side of the equals. Yours might have been on the left, but you should still have the same answer. If you remember from our properties a little over a week ago, it doesn't matter which side the x is on because it still equals the same thing. So we have an example here to use. I would recommend that you come back to this lesson repeatedly if you need to. We will be spending quite some time on solving equations. You will have some issues and struggles, but that's to be expected. The key is follow your process, follow your notes. Be very careful with your integer rules. You'll be using this video for probably the next week, and you can reference back to it time and time again. I hope that this was helpful. I will talk to you guys later.